All right, so in this video, we are going to learn to solve exponential equations. Remember, exponential equations are equations that have the variable in the exponent, right? So these are exponential because v is up in the exponent. Um, so there are a couple of methods that we're going to talk about. The first one is only applicable if we can get the base, meaning this big number down here, to match the base down here. If those bases match one another, then it's pretty quick and easy to solve the equation. Um, then the second method will be when we can't get those bases to match one another, then we'll have to use a separate method. But in the case of number one, where we have 5 to the negative 2v is equal to 5 to the 2v plus 1, for these two sides of the equation to actually equal each other, since the bottom number is the same, in order for these to be equal, that means this exponent would have to be equal to this one, okay? Maybe starting out with something a little bit more like obvious would help. So let's say I have like 4 squared equals 4 to the x power. They both have this 4 down here. If 4 squared is going to equal 4 to the x power, then I know that x has to be 2, right? Because 4 squared is 16. In order for this to equal this other side, the, the x would have to be equal to 2. So if the bases are equal and they match, then the exponents can be set equal to each other, because in order for the equation to be true, the and everything else is being the same, like on the bottom, right? Those exponents would have to equal each other. So let's look at number one. So I have 5 to the negative 2v equals 5 to the 2v plus 1. Because that base is the same, everything's the same on both sides of the equations, except for the exponents. In order for these to be true, those exponents are going to have to equal each other. So if those bases match, I don't even need to write them in the equation as I'm solving. I can just go straight to the exponents and set them equal to each other. So in order to solve this, I would try to get all the v's on one side. So I'm going to subtract 2v from both sides. But technically, I could have added 2v to both sides too, but I just want to get all the v's over to this left-hand side. Whichever method you use, you'll get the same answer. If I would have added 2v to both sides, eventually I get the same answer. So negative 4v equals, that goes to 0. So negative 4v equals 1. Divide both sides by negative 4. And v is equal to negative 1/4. Okay, so again, if you can get these two base numbers to match and there's nothing else going on down here, like, or out here, you can just go ahead and set those equal to each other. So let's look at number 2. So I have 5 to the 2v plus 2 equals 25. Now 5 and 25, the bases do not match. However, I can write 25 with a base of 5, right? Because 25 is just 5 squared. So I could rewrite this equation to be 5 to the 2v plus 2 is equal to 5 squared. And right, 5 times 5 is 25. So that's just another way to write the same number. Now my bases match. They're both 5s, so I can take and drop them and just look at the exponents. So I know that 2v plus 2 must equal 2 in order for these two equations to equal each other, two sides of the equation to equal each other. Get v by itself by subtracting 2 from both sides. So 2v equals 0. Divide by 2. 0 divided by 2 is just 0. So in that one, v would have to be 0 for those two sides to equal each other. So on number 3, the base already matches this side and this side. They are equivalent. Because of that, I can just take the exponents and set them equal to each other and then solve for v. I want to get this v moved over, so this would be negative 4v equals negative 3. Divide both sides by negative 4. So v is equal to 3/4, right? Negative 3 divided by negative 4 would be positive 3/4. All right, on number 4, I have 36 and 216. So those don't match, but I think I could get them both to match each other. Let's see, 36 times 36 is 1296, so that's way too big. But I could write 36 as 6 squared, right? 6 squared is equal to 36. Now the problem here is that it already has another exponent of negative 2x on it. So just the 36 is 6 squared. So I'm going to put parentheses around that because it still is raised to the negative 2x power, right? So I'm just replacing this 36 part with 6 squared, but then that is still raised to negative 2x. So let's do the same thing over here. I'm going to grab my calculator. I know that 216, like 6 goes evenly into it. I just have to make sure that I can get a base 6 on that. So what I'm going to do is I'm going to do 6 times 6, which equals 36. And then I'm going to times 36 by 6. That gives me 216, which tells me that 6 to the third power is equal to 216. And then that's still raised to the 2 minus x. Again, I'm trying to get the bases to match so that I can solve the equation using the exponents. Because 36 is 6 squared and 216 is 6 to the third, I can replace the 36 with 6 squared. I can replace the 216 with 6 to the third. But I can't forget that these are also then raised to another exponent. Now remember, if I have an exponent and I raise it to another exponent, I can simplify that by multiplying the exponents together. Remember our exponent rule, if I have an exponent raised to another exponent, multiply the exponents together. So this is the same as 6 to the negative 4x, and then this would be the same as 3 times 2 is 6, and 3 times negative x is negative 3x. So now those bases match. I've multiplied the exponents together to simplify, and so now I know that I can get rid of those bases and just set the exponents equal to each other and then solve for x. So I want to get all the x's on one side, so I'm going to add 3x to both sides. So negative x equals 6. And then divide both sides by negative 1, so x equals negative 6. Okay, so if you can get those bases to match, do so, and then you can set those exponents equal to each other. Now on number 5 here, I cannot get 2 and 46.2 to have the same base. There's just no way to do that. So in this one, I'm going to use a little bit different of a method. The first step that I'm going to use is that I am going to change this to log form. So change to log form. So log base 2 of 46.2 equals n. Okay, right, I'm just changing to log form. And then the second thing I want to do is use the change of base formula in my calculator. So I'm basically just solving this in my calculator. M equals log base 2 of 46.2. But remember our change of base, since your calculator does, when you hit the log key, it has base 10. We have to put this in our calculator as log 46.2 divided by log 2. And that will give us the result that we want. Or you can use natural log, remember. We're just changing the base so that we can get the result here on our calculator. Some of the calculators, you can actually change the base, the little base number here from being a 2. But any calculator that has a log on it, you can use this change of base. So log 46.2 divided by log 2 is equal to 5. Let's see, it says round to the nearest 10,000th. That means I'm going to keep 4 decimals. So 5.5298. Okay, so same thing on number 6. First thing we want to do is change to log form. So log base 19 of 31 equals x. And then we're going to put this in our calculator using our change of base. So log 31 divided by log 19. And we're going to keep 4 decimal places, 1.166, and I'm going to round the third one up to 3, or the fourth one up to 3. Okay. So if we can't get those bases to match, then we want to use this change forms and then change of base. So on this one, my exponent is not just a variable, it's 2 times a variable. So we still use the same method. First, we're going to change forms. Log base 5 of 78 equals 2p. But now we have to get p by itself. To do that, right now, p is times by 2. We'll have to divide both sides by 2. Okay, so over here, I'm going to use my change of base. This would be log 78 divided by log 5. And then I'm going to divide that whole thing by 2. So in my calculator, I'm first just going to do log 78 divided by log 5. I'm going to hit enter, and then I'm going to divide that whole thing by 2. So this is equal to 1.3535. Okay, so number 8 will be very similar to that. I'm going to change forms. Log base 13 of 65 equals 7.3b. And then to get b alone, I'm going to have to divide both sides by 7.3. So in my calculator goes log 65 divide log 13 divide 7.3. Okay, so log 65 divide log 13. Now if your calculator, when you put log, if it has parentheses, it opens a parenthesis, you are going to have to make sure, so like sometimes when you put log in the calculator, it puts a parenthesis right there and you put your number, you are going to have to definitely close that before you divide by log 13, and then close that before you divide by 7.3, or you will get the wrong answer because it will put that other second log inside the first log. So make sure you close that parenthesis off before you divide. All right, so this would be equal to 0.2229. All right. So on these last few, we have other steps going on. The first thing we need to do before we change to log form, I guess, so this is going to be step 0 if we have other stuff going on like -3 out here or -6. So our 0 step here is going to be to get the base and exponent term alone on one side. Okay, what do I mean by that? I mean, as I look at this, the base with the exponent is 17 to the x. I need to get that alone on one side before I begin. Over here, it would be 6 to the -8x. The base with the exponent needs to be all by itself on one side. On number 11, that would be 7 to the 6p needs to be alone on one side before I begin. And on 12, it would be 18 to the x minus 7 needs to be alone. Okay, so that's the first thing. I don't think I have any more here. Get that base with the exponent all by itself. Then our steps are the same. We want to change to log form, and wow, my handwriting is great. Change to log form and then use change of base and get your calculator. And then you'll have it. Okay, so let's try number 9. So in order to get 17 to the power of x alone on one side, I need to undo times 3. So I'm going to divide both sides of the equation by 3. So that those will cancel 2 and 1. So 17 to the x power equals 9. Now I can change forms. This would be log base 17 of 9 equals x. And then I can go ahead and put this in my calculator as log 9 divided by log 17. Okay, so log 9 divided by log 17. It's not a bad idea to just, if you have a calculator, put these in with me, because then you can make sure you're entering them correctly. You're getting the same answers. Okay, on this one, I need the 6 to the -8x all by itself, so I need to get rid of -6, so I'm going to add 6 to both sides. So 6 to the -8x equals 3, and then change to log form. Log 6 of 3 equals -8x. On this one, I'm going to have to divide by -8 to get x alone. So this would be log 3 divided by log 6 divided by -8 is equal to x. Okay, and I'm actually not going to put that one in the calculator. I think we've got the method down here. So, all right, so on this one, I have to undo -7 by adding 7 to both sides. So 6 to the 7 to the 6p equals 62. Is that right? Yep. And then we're going to go ahead and change form. So log base 7 of 62 equals 6p. And then we'll have to divide both sides by 6. So in your calculator, you're going to put log 62 divided by log 7, and then divide that whole thing by 6. Okay, on number 12, we need to get 18 to the x minus 7 all by itself. we have two different things happening. We have it multiplied by negative 1.7, and we have it added, or we have a plus 1 out here. I need to undo both of those. Just remember, you always undo plus or minuses before you undo times and divide. So we're going to subtract 1 from both sides first. So I've got negative 1.7 times 18 to the x minus 7 equals negative 7. Now I need to divide both sides by negative 1.7 to undo that. So again, undo pluses and minuses always before multiplication and division. So now I have 18 to the x minus 7 equals, and I'm going to do in my calculator negative 7 divided by negative 1.7. That is equal to 4.1176. It goes on, and I'm actually just going to go ahead and round it off to 4 decimal places. It's always a good idea to try not to round till the very end, but we'll do that here anyway. So now change log to log form. Log base 18 of 4.1176 equals x minus 7. And so now on this one, we're going to have log 4.1176 divide log 18 in my calculator. Then I'm going to have to add 7 to that result, right? Because to get rid of this, I've got to add 7 to both sides. So do log 4.1, put it in my calculator really quickly, 1176, close the parenthesis, divide by log 18, divided by log 18, close the parenthesis. I'm actually going to hit enter now, and then I'm going to add 7 to that. So that would give me x equals 7.4896. All right, guys, give them a try, and I hope you have a lovely day. Shoot me an email if you have any questions, and I'll see you tomorrow.